Okay, so sorry about that. Sorry about that. All right, so we're doing the. You should have written a sentence of what an inverse is. It's the opposite of a function, opposite of a point, opposite of anything is an inverse. On the notes, we're labeling all the sides of the squares. We know all the sides are the same. Now, it says complete this table by showing the relationship between the length and the area. Okay? Now, let's find the area of each of these squares. We said it's side times side, right? So 1 times 1, what do I get? 1. What about number 2? What do I do? What do I multiply here? 2 times 2 is 4. What about the third one? 3 times 3 is 9. So, can we fill in that first table? If the side length is 1, what's the area? If the side length is 2, what's the area? And then for 3, okay, can you plot those 3 points on this graph? Now remember, some people still struggle with graphing. It's x comma y, which means horizontal before vertical. So if it's 1 comma 1, we're going to start at 0, 0, so over 1, up 1, put a point there. Let's do that. Right 1, up 1, boom. Now let's plot 2 comma 4. Now it's x comma y. So x is 2, y is 4, so that means right 2, up 4. Put a point there. And then 3, 9, 3 to the right, 9 up, 3 comma 9 is right there. So has everyone graphed those 3 points? So all we're doing is putting the area on the left-hand side now. So if the side length is 1, what's the area? 1. Okay, so the area, when the side length is 1, we put 1. The side length is 2, we put 4. The side length is 3, we put 9. Now, can you plot these points? So 1 comma 1 is the same point, so put a point there at the same point. Now, 4 comma 2. 4 to the right, up 2, put a point there. And then 9 comma 3. That's right 9, up 3. So go ahead and put a point there. What do you notice about these points? A good observation. Let's write that on the back. So go ahead and flip it over. If you plot those 3 points, how does table B relate to table A? It was just what? Flipped. Yeah. Flip or switch. Actually, you can say switch X and Y. Now, number 2. On number 2, after the plotted points, what do you notice about the points between the graphs? They're symmetrical across y equals x, across the diagonal line. So anytime you graph them, they'll be foldable across that diagonal line, right? So here's your definition of inverse. I'm going to put little brackets around it. All you got to do is underline the last part. switch X and Y. Didn't I tell you it was this easy? You're switching X and Y. That's all you're doing. Okay? That easy. Now, look at example 1. If I give you 3 points, a set of 3 points, and I say find the inverse, first of all, I want everyone to see this. F with a little -1, X means inverse. Okay? If I ask you for the F to the -1 power, or F inverse X, all you got to do is take the order and switch it. So instead of 1, 2, it's going to become 2, 1. All I did was switch them. The sign stays the same. Okay? 3, 6 becomes 6, 3. -2, 9 becomes 9, -2. Do you see that all we're doing is switching the order? Cool. Let's try a few here. Number 1, -3, 6 becomes good. 6, -3. 7, 6 becomes 6, 7. And then -2.4, comma 8.3 becomes 8.3, comma -2.4. Please don't click. All right, now, real quick, because you have to finish that. Please. Okay, good. But real quick, go. Number 2. Now, what if it's just a bunch of letters? Same thing. Just switch the order. Cool? Let's write it down. Instead of AB, it's going to be BA, like the Cowboys. All right, DF is F, comma D. MX becomes XM. Put them all in parentheses with a bracket. Yes, commas in between. Now, even if it's a bunch of random names from the Star Wars universe, you can still just switch the order, write them down, okay? I didn't make this, but Miss Testa likes Star Wars. Han Solo, comma, Harrison. Yo. The 13th, Thursday. Princess Leia, comma, Carrie. And then Luke, comma, Mark. Sounds like a country singer. I know it's kind of messy, but it is what it is. So Princess Han Solo Harrison, Princess Leia Carey, Luke Mark. You can flip it to the next slide, or the next page, I should say. So far, we've only done points, ordered pairs, coordinates, whatever you want to call them, okay? Now, on the next page, we have what's called mappings. Mappings. What changed from this one to this one? Right, the -1, but in the ovals, what changed? They flipped yet again. Same thing, right? Except what did not change? The numbers and letters did swap, but between that, what do you notice? Did the arrows change? The arrows are still going from left to right. So those are our 2 observations. You switch the ovals, but you don't change the arrowhead, okay? We switch the left and right ovals, but still point right. Cool. So what should I do on this example to get the inverse? Wait, put it down. What should I do on this next one to get the inverse? What do I do? Tell me what I do. On which oval? On the very right one. So we're going to put all the left ones into the right one. 1, 2, 3, 4, 5. What else? Okay, 3, 4, 5, 6. Wait. So think backwards now. So 3 goes to what? Right. Okay, 3 goes to 2, and my arrow still points right. And 4 goes to what else? So you see how 4 had 2 things coming out of over here? So yep. Very good. So you have to kind of think of, on this one, the arrow's going backwards now, but you write it pointing to the right, okay? So did everyone get that? You switch all the contents of the left and the right oval, and then you have to backtrack your arrows, just make sure they're pointing to the right. Right now, in the middle of the notes. Oh, if you can hold it, because we're going to finish up here soon. In fact, we only have one more problem, right? Yeah. Can you wait for one problem? Okay. Now, here's a multiple choice problem. No, D. A and D. Yeah. Oh no, it has a positive 10. All the points have been flipped around. Okay. Now you tell me, was that easy or hard? So now day 2 is the assignment on it, so we're doing 1 and 2 all in one day because it's not that hard, right? So, assignment, and I'll explain. If you have questions on it, we'll have a quiz on this stuff tomorrow, but it should be easy because you can switch the order, right? Okay.